So the instructions for this that you'll see on the test are solve over the interval from 0 to 360 degrees. And your first question that I want you guys to do, you have seen this question before actually on a test. Maybe not the exact thing, but this type of question. So sine of x is equal to 0.734. Okay, so I need not one answer, but two answers. Or if I take the sine of that angle, I get this decimal. So you will need to use a calculator. And the other thing that you will need is the remembrance of this little chart. All students take calculus. Okay, do we all get 47.22 for the first one? Yes, that's this angle here, right? So to find my sine angle, the other one is going to be in this second quadrant because that's where it's positive. So to find that angle, I'm going to do what? 180 minus that, which gives me 132.78 degrees. Okay. Okay, so cotangent of x is equal to 2.43. Is there a cotangent button on your calculator? No. No. So how am I going to have to rewrite this? Tangent.
Tan inverse 1 over 2.43.
Yes. So tangent is the same as 1 over 2.43, right? Now we can inverse both sides and find out what our answer should be. Again, make sure you get both answers. There should be 2 for this one in degrees. From walking around, I do like how you guys kind of show it in this picture here because then it's like a good remembrance that you need to, right? In the first quadrant, you should have gotten that 22.37 on your calculator, and then tangent is also positive in the third quadrant, so that's how we get the 202.37, which we find by taking 180 plus the 22.37. So these are the instructions that you will see for the solving. All of the solving ones are going to be giving exact answers, not approximate. So even if you're using your calculator, I don't care. You still need to give me the answers that are on the unit circle, okay? So the first question that I'm going to have you guys do to solve is 3 cosine of x plus 3 is equal to 0. Again, this once you get to this point here, after you've isolated that trig function, you're asking yourself what angle gives me a cosine value of -1. This case, there's only one of those, right? So you're only going to have one answer. But sometimes you might have 2, you might have 3, you might have 4 answers for these type of questions, okay? All right, next one I want you guys to try. Let's do 2 sine of x plus 3 is equal to 4. Okay, next one we're going to do is tangent of x minus cotangent of x is equal to 0. Okay, there is more than one way that you can solve this. So however you think you want to go about it, try it out, and then we'll talk about maybe a few different ways that you could solve this problem. Okay, easiest way, in my opinion, to solve this is to just add the cotangent of x over, and then just ask yourself, when is the tangent and the cotangent values the same on your unit circle? So that means my x over my y, or my y over my x. What values are those going to be the same at? But the radians. So that would be like at pi over 4. Where else? Oops.
5 pi over 4.
5 pi over 4. Where else?
There's multiple more?
Yeah. 7 pi over 4. And 3 pi over 4. So if I would have, instead of writing it like cosine and sines, I would have maybe just left it like tangent of x minus 1 over tangent of x, right? And then this, we could do common denominator, so tangent squared minus 1 over tangent of x is equal to 0. And now if I'm solving this like an equation, I can go ahead and cross multiply here, right? Multiply that tangent of x over, and I get tangent squared of x minus 1 equals 0. Add the 1 over, tangent x squared is equal to 1. And then if I want to get rid of a squared term, like if I was solving the equation x squared equals 1, what would my answers be? Square root, so I get plus or minus 1, right? So if I square root, I'm going to get tangent of x is equal to plus or minus 1. So where or what angle on the unit circle am I going to have a tangent value of a positive 1 or a negative 1? Does that make sense? So when you take square roots, make sure you have a plus or a minus sign in front of your answers to make sure that you don't miss any of those. Okay, here's your problem. Again, there is more than one way that you could solve this. you are trying to figure out where is cosine squared equal to sine squared. So a lot of you guys, I saw you do this. Take the square root of both sides, yes? And then you said, okay, cosine of x is equal to sine of x. Well, if I take a square root and it's an equation, I have a plus or a minus and a plus or a minus, right? So we're looking at where is my cosine value equal to my sine value, positive or negative, right? So that's going to be the answers of pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Or you can think to yourself, like, honestly, you might not have even had to do any of this because you're asking yourself, okay, well, what x value squared is going to equal the y value squared on my unit circle, right? So it doesn't matter if they're negative or positive. They're both going to end up being positive in the end, right? Another way to do this, I could rewrite cosine squared or sine squared in terms of one of the trig functions, Pythagorean identities, like number 9. So sine squared is the same as 1 minus cosine squared, right? If I add the cosine squared over, I get 2 cosine squared is equal to 1. Okay, divide by 2. Cosine of x is equal to 1/2. How do I get rid of the squared? Square root it. And then if I want to square root something in an equation, that's going to give me a plus or a minus square root of 1/2, which is the same thing as plus or minus 1 square root of 2 over 2 if I rationalize that, right? So if you look on your unit circle, where's your x value, a positive or a negative square root of 2 over 2, that's where these 4 answers come into play. Does that make sense? Okay, go ahead and try out tangent squared of x is equal to 1/3. Solve for x. And if I simplify this, this would be the tangent of x is equal to plus or minus 1 over the square root of 3, which you could rationalize if you want, but you don't necessarily have to. So if I looked at my unit circle and asked myself, what angle am I going to get a plus or a minus 1 over square root of 3? What angles would you tell me? Pi over 6. 5 pi over 6. 7 pi, and 11 pi over 6. Okay, be careful on this one. Sine squared plus just cosine is equal to 1. So it's not sine squared and cosine squared. Okay, I've got 2 different trig functions. I will tell you right now, you are going to have to use a trig function of some sort from your identity sheet in order to solve this, because there's nothing else we can do. Okay, I would go ahead and choose to rewrite sine squared in terms of cosines because I've got a trig function or an identity for that, number 9. So I could rewrite this as 1 minus cosine squared plus cosine equals 1. Can I get rid of those 1s? Sure can. And now I'm just left with a negative cosine squared plus cosine of x is equal to 0. What can I do on the left side there? Take out a cosine. I'm going to take out a negative cosine. You don't necessarily have to, but you can if you want. And then you get a cosine of x plus 1 on the inside. So zero product property tells me I got 2 equations I'm going to solve. So negative cosine of x is equal to 0 and cosine of x plus 1 equals 0. So this is really the same thing as cosine of x equals 0, right? Divide by the negative. And this one's cosine of x is equal to negative 1. So where is my x value on my unit circle? Either 0 or negative 1. X value is 0 at pi over 2 and 3 pi over 2, right? And then x is negative 1 at what angle? Pi. So those 3 would be my answer. Okay, this should be... Oops. Why is it not letting me erase it? That should be a minus, right? So then this all cancels out. We fix this here. This becomes a minus. This is a positive. So where's the cosine positive 1? And that should be at 2 pi. Thanks for finding my mistake there. Does that make more sense? Yes. Great. So technically, I'd probably be pretty lenient on this on the test, even though the interval is technically from 0 to 2 pi, right? Not including 2 pi. So instead of 2 pi, the better answer would be 0. Same thing. I would take off maybe like a 1/4 point out of a 3-point question, okay? Okay, last question. Sine of x, cosine of x is equal to 1/4. Now, I'm going to kind of help us guide through this one a little bit because we haven't seen a ton of questions like this before. Now, is there anything that I could do for sine and cosine there to get one of those trig functions to go away?
No.
No. So instead, if I see a sine and a cosine, does that look like a double angle identity? Part of it, at least? It looks partially like number 24, right?
Yeah.
So let's go ahead and multiply this 4 over to both sides. So I have 4 sine of x cosine of x is equal to 1. Okay, number 24's identity, we did talk about how we could rewrite this. This could be rewritten as 2 times 2 sine of x cosine of x, right? And this from identity number 24 can change into what? Sine of 2a. So I have 2 times sine of 2x is equal to 1. So if I divide by 2, I get sine of 2x is equal to 1/2. Now this is not just like what angle is going to give me a y value of 1/2 anymore because there's a 2 in front of that, right? So we need to think, how do I undo the sine? Well, what's the opposite of sine? The sine inverse. So if I take the sine inverse of both sides, those go away, and now I'm left with 2x is equal to the sine inverse of 1/2. So where on your unit circle, this is the difference between simplifying and solving. If I was just simplifying the right-hand side, I would only have one answer because it has to be in quadrants 1 and 4, right? But since I'm solving this equation, I'm looking at what y value is a positive 1/2. What two angles give me a positive y value of 1/2? Pi over 6 and 5 pi over 6, right? So I've got two equations I'm going to solve. I'm going to solve the equation 2x is equal to 5 pi over 6 and the equation 2x is equal to pi over 6 because that is where my y value on my unit circle is equal to 1/2. Whereas if I was just simplifying the right-hand side, my only answer would be the pi over 6. Difference between simplifying, solving, one answer versus two answers there. Does that make sense? Kind of a little bit? Okay, so then if I'm solving for x here for both of these, what do I have to do? Divide by 2. So if I divide by 2, I get x is 5 pi over 12. And then if I divide by 2 over here, I get pi over 12. Okay, kind of tricky. This part here, going from this line, this line here to this line and solving it is the hardest part there at the end.